Welcome to our new topic. Today we will talk quadrilaterals and especially parallelogram, rectangle, square and rhombs. Let's start. What is quadrilateral? Quadrilateral is a polygon that has four sides. Let's start. A quadrilateral is a polygon that has four sides. Unless otherwise stated, the term quadrilateral refers to a figure such as A, B, C, D, and in which the line segment sides, these line segment sides, lie within a single plane. When the sides of the quadrilateral are not coplanar, let it be like that. Let it be a plane, and if the sides of the quadrilaterals are not coplanar, this is called skew. Let it be N, P, M, and Q. As you see, 1, 2, 3, 4, this quadrilateral also has four sides. But what is the difference between them? All these sides of this quadrilateral lie within one plane. But here, the sides of this quadrilateral lies in two plane. Okay, this is called coplanar. Let me write coplanar, and this is called skew. But we will generally consider quadrilaterals whose sides are coplanar. Let's start with a parallelogram. A parallelogram is a quadrilateral in which both pairs of opposite sides are equal. Let me show you. Let it be a quadrilateral. We, R, S, and T. Okay? If the opposite sides are parallel, then this is called a parallelogram. And always the set of parallelograms is a subset of quadrilaterals. Okay? This is parallelograms and this is quadrilaterals. So, a diagonal of a parallelogram separates it into two congruent triangles. Let it be a diagonal. S is a diagonal. And it separates this parallelogram into two congruent triangles. It means that we are S and the triangle VST are congruent. We are S and the triangle VST are congruent. The corollary of this theorem is that the opposite angles of a parallelogram are congruent. These opposite angles are congruent. Okay, and also the opposite sides of a parallelogram are congruent. These opposite sides are also congruent. The diagonals of a parallelogram bisect each other. Let's write what we talked. And the angle V is congruent to angle S. The angle R is congruent to angle T. Also, the diagonal VS bisects the diagonal RT. Okay, here let it be the point O. VO is equal to OS, also RO is equal to OT. Let's write the angle R is congruent to angle T or equal. Also, the angle V is equal to angle S, and the diagonal VS and RT bisects each other, and VO is equal to OS. RO is equal to OT. So this is a brief information about parallelogram. Let's start our main subtopics, subtitles, the rectangle, square, and rhombus. So, rectangle. A rectangle is a parallelogram that has a right angle. Any reader who is familiar with the rectangle may be confused by the fact that the preceding definition calls for only one right angle, but now all the four angles of a rectangle are right angles. All angles are rectangle are right angles. It means that they are equal to 90 degrees. And also the diagonals of a rectangle are congruent. The diagonals are congruent. It means that they are equal to each other. Let it be A, B, C, and D. A is equal to B and is equal to C, and also C is equal to D, and it's equal to 90 degrees. Also AC is congruent to the diagonal BD. Also, as a rectangle is a parallelogram, all the properties of parallelogram is satisfied here. It means that the opposite sides are parallel and these opposite sides are equal, congruent. Also, the diagonals bisect each others. It means that let it be the point O. AO is equal to OC and BO is equal to OD. And also one diagonal makes two congruent triangles. And our new figure is the square. A square is a rectangle that has two congruent adjacent sides, as is easily seen from the figure that the angle A, B, C, and D both are right angles, and also all these sides are congruent. A square is a rectangle. All rectangles are parallelograms. Let's write all rectangles are parallelogram, and some rectangles are square. Some rectangles are square. It means that if both sides, all sides of the rectangle are equal to each other, then this rectangle is square. And also all the diagonals of rectangle are equal, congruent to each other, and they bisect each other. Let's write the angles are right angles, and all the sides are congruent. Also, both two diagonals are equal to each other. They are congruent. Also, they bisect each other. It means that AO is equal to AC and BO is equal to OD. Let's give a brief information about rhombus, and then we have plenty of examples and also Olympiad exercises about quadrilaterals. So, a rhombus is a parallelogram with two congruent adjacent sides. Here in the given example, AD and AB the adjacent sides of the rhombus. Okay, and because a rhombus is a type of parallelogram, it's also necessary that AB, the side AB, is congruent to the side DC. Okay, and also AD is congruent to BC. Here, from this, we have corollary that all sides of a rhombus are congruent. All sides are congruent. Let's write. And the diagonals of a rhombus are perpendicular. Okay, the diagonals are perpendicular. It means that here we have a right angle. As is easily seen from this figure, that the diagonals of the rhombus makes four, you see, four triangles with right angle. Yes, and here the Pythagorean theorem appears. So what is the Pythagorean theorem? In a right triangle with hypotenuse of length C and legs of length A and B, it follows that C square is equal to A square plus B square. So let's apply this theorem to this rhombus. Here, let it be the legs A and the leg B. Okay, only this. This is the leg A and leg B, and this is the hypotenuse. Okay, let it be the hypotenuse C. The square of the hypotenuse is equal to the sum of the squares of the legs. And now we have a question for Olympiad about quadrilateral and parallelogram. And ABCD is a square of side 2 centimeter. It means that AB is 2 centimeter, BC, DC and AD are equal to each other and 2 centimeter, and EFGH are the midpoints of the sides. E is a midpoint of AB. AE is equal to EB, and both two sides are equal to 1. Also here BF is equal to FC, DG is equal to GC, AH is equal to HD, and all these are equal to 1. And what is the area of the sides PQ, RS? What is the area of this? We need to find. Now EBGD is a parallelogram because each pair of opposite sides are equal and congruent, parallel. DE is parallel to GB and lengths are equal. Also EB is parallel to DG and the lengths are equal. Also AFCH is a parallelogram because each pair of opposite sides are equal and parallel. So in triangle ABF, E is midpoint of AB. E is a midpoint of AB, and EP is parallel to BQ. And EP parallel to BQ. Here EP is parallel to BQ, and therefore it's obvious that P is midpoint of AB. Sorry, EQ. We will get this corollary by convert of midpoint theorem. So let AP be X, then PQ, as you know that AP is equal to PQ, then PQ also should be X, and BQ is also X. In this triangle ABF, we know that AF is a hypotenuse, and the square of AF is equal to the square of legs AB plus the square of BF. And it's clear that AB is equal to 2 and BF is equal to 1. Here we get that the hypotenuse AF square is equal to 2 square plus 1 square, and the AF is equal to the square root of 5. And now in our triangle BQF, in this triangle, this is a right angle triangle also, and BF is hypotenuse, so BF square is equal to the square of BQ plus the square of QF. and BF is equal to 1, as is clearly seen. 1 square is equal to, we denoted that BQ is equal to x. It means that x squared plus what is QF, the length of QF. We know that we get that the length of AF is equal to the square root of 5. Yes, this is equal to the square root of 5, and here we have 2x. If we subtract this 2x from AF, we get QF, and we can write that instead of QF, the square root of 5 minus 2 times x squared. Here we get that 1 square is equal to x squared plus 5 minus 4 times the square root of 5 times x plus 4 times x squared. And if we make it simple, we get that 5 times x squared minus 4 times square root of 5 times x plus 4 is equal to 0. Here we get the root x is equal to 2 over the square root of 5. Here we get x, and as you know that this is a square, the area, I'll write it here, area of the square PQRS is equal to x squared, and this is equal to 2 over square root of 5 square. We get 4 over 5. This is our result. And this is our next Olympiad question. Here we have quadrilateral A, B, C, D. This is any quadrilateral. So let K, L, M, and N be the midpoints of sides of quadrilateral ABCD. This means that L is the midpoint of BC. M is the midpoint of CD. It means that CM is equal to MD. N is a midpoint of AD, and K is midpoint of BA. Here are X, Y, Z, and T, and these points are the intersection of the line joining vertices to the midpoints of opposite side. Okay, they are vertices A, B, C, and D are vertices joining this vertex to the opposite side, the midpoint of the opposite side, and join this vertex with the midpoint of opposite side. Also join D to the midpoint of opposite side, K, and join C with N. And here we have little triangles. The triangle of the area of this triangle is D. The area of that triangle is A. The area of this triangle is B, and the area of this triangle is C, as you see. And also we have the areas A1, A2, A3, and A4. If we subtract the area X, Y, Z, T from the area of quadrilateral. The remaining areas are A2, A3, A4, and A1. So, we join diagonal AC and BD. The diagonal AC and BD. In triangle ABC, sorry, in triangle BCD, B, C, and D, in this triangle. And now in a BCD, in this triangle, BM is median because M was the midpoint of CD, and if we join the vertex B with the point M, we get the median. And we know that median divides triangle into two equal areas. And here in this triangle BCD, the area of BCM is equal to the area of BMD. Yes? And here the area of BCM is equal to B plus C plus A1. Look at this triangle. The area is equal to B plus A1 plus C. And the area of BCD, where is BCD? This, we know that BMD is equal to BCM. We get that area of BCD is equal to 2 times B plus 2 times C plus 2 times A1. Also, the area of BAD, B, A, and D is equal to the area of DKA plus the area of BDK. Yes, we get that the area of BAD is equal to 2 times A plus 2 times D plus 2 times A3. So the area of ABC is equal to, let's find A, B, and C. Here, this triangle is the sum of two triangles, ABL and ALC. The area of ABL is equal to A plus B plus A4. And the area of ALC is also equal to A plus A4 plus B, because the median divides this triangle into two equal areas. So we get that the area of ABC is equal to 2 times A plus 2 times B plus 2 times A4. And finally, the area of ACD is equal to, let me find, A, C, and D. You know, here we have NCD and ACN. They are two equal triangles, and the area of NCD is equal to C plus A2 plus D. And we get that from this area. The area of ACD is equal to 2 times C plus 2 times D plus 2 times A2. And let it be 1, let it be 2, 3, and 4. If we add 1 and 2, we get that the area ABCD is equal to 2 times the area of ABCD. If we add to BCD, and ABD or BAD, if we add two triangles, we get that the area of ABCD is equal to 2 times A plus B plus C plus D plus A1 and A3. Yes, and if we add 3 and 4, we get the area of ABCD is equal to 2 times, again, A plus B plus C plus D plus, here we get A4 plus A2. Please look at these examples and try to understand what we will get. And let this equation be 5 and let this be 6. We know that the area of ABCD, it is also the area of ABCD, and we get that this equation is equal to this equation. Yes, 5 is equal to 6. Thus, we get that A1 plus A3 is equal to A4 plus A2. Because ABCD and ABCD are the same, also we can divide both of these sides by 2. We get that A1 plus A3 is equal to A4 plus A2. And we know that here the area of X, Y, Z, T is equal to if we subtract the area of A, B, C, D, if we subtract the area of B, C, D, A, and A for A1, A2, A3, we will get X, Y, Z, and T. And now, keep your attention, please. The area of ABCD is equal to 2 times A plus B plus C plus D plus A1 and A3. Yes, if we subtract from this side, we will cancel A1, A2, A3, A4 is equal to 2 times A1 plus A3. Yes, here A1 and A3, A1 2 times A1 and A3, and A1, A2, A3, A4 are cancelled out. And now Okay, we will get that 2 times A, B, C, D can be cancelled out by A, B, C, D, and we will get just one A, B, C, D. Okay, I will write it there. Two times A, B, C, D plus A1, A3 minus A, B, C, D plus A1, A2, A3, A4. We will get that this and this are cancelled out. We will get 2A, 2B plus 2C plus 2D minus A minus B minus C minus D, and the area is equal to A plus B plus C plus D. This result is the area of X, Y, Z, and T. So this is our today's topic. Hope you can understand the Olympiad questions. If you have any question, any unclear parts, please let me know by asking below in the comment. See you in our next video.